The reverse transcription, or cDNA synthesis step, is one of the most common sources of variation in gene expression analysis by RT-qPCR. The sensitivity and dynamic range of qPCR are important for accurate quantitation of your starting RNA. Ideally, the CT of a qPCR should correlate well with the initial number of copies of the RNA target. In many cases, this is not observed. For example, undetectable or higher than expected CT values could be a result of poor sensitivity. These are the top 5 reasons for low sensitivity. Reason number 1 is inhibitors of reverse transcriptase present in the RNA samples. These inhibitors affect enzyme activity and lower the cDNA yield. To overcome this, optimize the RNA isolation step and choose a robust reverse transcriptase that is less sensitive to inhibitors. Reason number 2 is RNA degradation from contaminating nucleases or extra handling of your sample. Degraded RNA may result in cDNA yields that are too low for detection in qPCR. To overcome this, avoid freeze-thaw of samples and use a highly sensitive reverse transcriptase with an optimized buffer to detect low RNA input. Also, include RNase inhibitors to prevent contamination. The third reason is complex RNA secondary structure, which can impair the reverse transcriptase's binding to RNA and thus inhibit cDNA synthesis. To overcome this, perform cDNA synthesis at a higher temperature to remove secondary structures. Reason number 4 is false positives in RT-qPCR, which are caused by genomic DNA contamination that leads to overestimation of the amount of RNA yield. To overcome this, use DNase treatment to remove contaminating double-stranded DNA from your sample. You can add the DNase prior to the reverse transcription step without risking damage to or loss of your RNA. Reason number 5, seemingly trivial, is variation from sample pipetting. To overcome this, calibrate your pipetter and limit pipetting steps. Even better, reduce pipetting variation by using a single tube master mix. Resolve many of these common challenges by using a master mix in an optimized buffer that works well with a wide range of template amounts, even with suboptimal purity or complex secondary structures. Superscript 4 Velo Master Mix contains a robust, thermostable reverse transcriptase and all necessary reaction components in an optimized buffer. Using Superscript 4 Velo Master Mix allows detection of both low copy and high copy targets, which means even poorly expressed genes can be discovered. Just add your RNA to Superscript 4 Velo Master Mix to obtain consistent RT-qPCR data. And for complete elimination of genomic DNA, supplement the Superscript 4 Velo Master Mix with ezDNase in your RT-qPCR assay.